Assalamu alaikum everyone, and welcome to this video in which we are going to be covering a concept called momentum. Now this is a topic that has only been added to the A-level syllabus from this year onward, from May June 2020. So before we start, I would assume that most of us have an intuitive understanding of what momentum means already. So for example, if you see a guy who's running really fast, you would assume that the person has a lot of momentum. So for example, if this guy is running at let's say 4 meters per second, you have another guy here who is running at let's say 7 meters per second. Most of us would intuitively think that the second person has more momentum than this first person. Similarly, if you see a big guy like this third one, you would assume that this person has a higher momentum if he was running at the same speed as this last person. Think about the difference it would have in impacts if they both were to run into somebody at that speed. So this person who has a higher mass is going to have more impact in a way. Now, if we were to look at the formal definition of momentum, this understanding we had intuitively is going to make sense. So, momentum is actually defined like this. Momentum equals the mass of the object multiplied by its velocity. So, if we were to write this in symbols, it's going to be P equal to m times v. So we denote momentum by p because we already have m taken by mass, so we cannot use that again. So p is generally the letter that is used to denote momentum. Now remember, the unit for mass here is kilograms. The unit for velocity here is, the standard unit is meters per second. So the unit for momentum is going to be kilograms meter per second. All right. Now let's apply this definition to our these runners here who are moving at different speeds. So let's assume the first person here has a mass of 70 kgs. This is the same person, the second one, so he also has the same mass. And let's say this third person here has a mass of 95 kilograms. Now let's calculate their momentums. So for the first person, it's going to be its mass multiplied with the velocity. So that's 70 multiplied with 4, which gives us 280. Similarly, for the second person here, he's the same person actually. So we have 70 multiplied with 7 because this now is moving at a greater speed. That's going to give us 490. And then for the last person here, that's 95 multiplied by 7. That gives us 665. So it's the same as what we understood before. The last person here has the highest momentum and the first person there has the lowest momentum. Now let's have a look at another example. So let's say you've got these two balls here, and both of them are moving in the opposite direction. So let's say the first ball here has a mass of 5 kilograms. The second ball here has a mass of let's say 4 kilograms. The first one is moving towards right at 8 meters per second. The second one is moving towards left at 4 meters per second. Now, how do you calculate the momentum for the first one? You would simply say momentum is going to be equal to mass, that is 5, times the velocity, that is 8, which gives you 40 kilograms meter per second. But now for the second ball, it's actually moving in the opposite direction. So if you notice here, we have velocity in the function, in the formula for momentum. Now remember, velocity is a vector quantity. Now since momentum is using velocity in its formula, momentum is also going to be a vector quantity. So in this case, if we were to consider this 8 meters per second towards right as positive, we'll have to say this other ball's speed, that is 4 meters per second, this has to be negative. So the momentum for the second ball is going to be calculated like this. So momentum is equal to 4 multiplied with minus 4. which is going to give you minus 16 kilograms meters per second. So remember, momentum is a vector quantity. Now, once we're done with the basics of momentum, there's another concept, and that is called conservation of momentum. Now, all conservation of momentum means is that if you have no external forces acting on a set of objects, their momentum is going to remain the same. So the momentum is going to be conserved. So let me give you an example. So let's say you have those two balls here again, and let's say the mass of the first ball is 6 kilograms, and it's moving at a speed of let's say 5 meters per second towards right. You have another object here, the other ball, and its mass is 3 kilograms, and it's moving towards left at, let's say, 4 meters per second. Now, how can you calculate the total momentum for the system? You will say, let's say this is the first ball, that is ball 1. You have the second ball here, that's ball 2. Now, the total momentum for the system is going to be mass of the first object multiplied with the velocity of the first object plus mass of the second object multiplied with the velocity of the second object. So mass of the first object is 6, the velocity is 5, plus mass of the second object, which is 3, multiplied with the velocity. Remember, it's in the other direction, so we consider this as negative. Now 30 minus 12, that gives us 18. So this is the total momentum that the system has right now. Now let's say they keep moving in these directions, and at some point they collide. Now after collision, let's say you are given that this blue ball, it moves in the right direction now at a speed of 3 meters per second. Now remember, its mass is 3 kg, so masses cannot change, of course. Now, how can you find what will be the speed of the first object, the red object, and also the direction it will be moving in? So remember, the total is going to be the same, that's 18. So let's calculate the momentum of the second system of objects. So again, we use the same method. So remember, the mass here is 6 kilograms. So we can say, and let's say the velocity here is v1. We have to calculate this, right? So 6 times v1 plus 3 times 3 should be equal to 18, because the momentum has to remain the same. So the momentum in this case is given by first object's mass multiplied by the first object's velocity plus the second object's mass multiplied by its velocity, and this is the total momentum for the system in this case, and it has to be equal to 18. Now we can solve for this v1. 6v1 is equal to 18 minus 9, which is 9. So v1 comes out to be 1.5 meters per second. Now since this is positive, it means that this red object has to be moving towards right at 1.5 meters per second after the collision. Alright, now let's consider one last example here, and that will cover all our cases then. So let's say you have the same two objects now, and what happens is that they're now moving in this direction like this. So let's say this is again 6 kilograms, and again it's also moving in the same direction at 5 meters per second. But now let's assume the second object is at rest, right? So it's not moving at all. How would you calculate the total momentum for this first system here? That's going to be 6 multiplied with 5 plus, this is going to be 0 because its speed is 0. So 3 multiplied with 0, that's going to give you 0. So the total momentum is going to be 30 in this case. Now what happens after collision is that these two objects merge to become a single object. Now the mass of this single object is going to be 6 plus 3, which is 9 kilograms. So using conservation of momentum, we can actually find out the speed at which this single object is going to be moving after after the collision. So the mass is 9, so we do not know the velocity. Let's call the velocity v. So 9 times v has to be equal to the total momentum we had before collision, that was 30. So we can find the speed like this: 30 divided by 9, that's going to give me 3.333. So that's 3.33 meters per second. Now let's look at a specific example from a paper. So let's say you have this questions, three small smooth spheres A, B, and C of equal radii and of masses 4 kg, 2 kg, and 3 kg lie in that order on a straight line. So what you can do is we can draw these spheres. We can say it's going to be the first sphere like this, that's A. We have another sphere, that's B, and we have another sphere, that is C. So what is happening initially? They have their masses given. So we have 4 kilograms, we have 2 kilograms here, and we have 3 kilograms in this last case. Now initially B and C are at rest. So this velocity is going to be 0. This velocity is also 0. And we are told that A is moving towards B. So it's moving in this direction. So let's consider the right side is positive, the left side is negative. So this is 6 meters per second. So we're going to have V1 equal to 6 meters per second. All right. Now, after the collision with B, so A moves in this direction and it's going to collide with B at some point. Now, after this collision, sphere A continues to move in the same direction but with speed 2 meters per second. So first of all, let's find out what is the total momentum in the first case. So remember, iska momentum is going to be 0 because the velocity is 0. This momentum is going to be 0. We only have the momentum for the first object here, and that is given by 6. So you can write in this order. So 4 multiplied with 6, that gives you 24. Now that is the total momentum that this system has before any sort of collisions. So once the object A collides with B, now the first object moves at a speed of 2 meters per second, right? And object C is still at speed 0 because we did not have any collision with that until now. What we are asked to find is what is going to be the velocity for this object, right? So आपको B की speed find करनी है. Like this. Now after the collision, remember the total momentum is going to remain the same, so we can use the conservation of momentum thing. We'll say the mass of the first object, that is 4, multiplied with the velocity of the first object, that is 2, plus the mass of the second object, that is 2, multiplied with the velocity of the second object, that is v2. We don't know what that is. That's what we have to find out. And this is going to be 0 in any case, so let's just write it down for clarity. 3 multiplied with 0, all of this has to equal 24. Alright, so now we can simplify. This is going to be 8 plus 2v2 equals 24. You can scroll down a little. 2 times v2 is equal to 16 and v2 is equal to 8 meters per second. So the speed of the second object is going to be 8 meters per second after that first collision. Okay, so let's look at this part. So it says sphere B collides with C, and in this collision the two spheres coalesce to form an object D. So coalesce means that they become the same object, right? Now, so in this case, our first object, that was A, there are no changes to that, right? It was moving at 2 meters per second after the first collision, yes, and its mass was 4 kgs. So we can just write it down like that. Its mass is 4 kilograms, and it's still moving at a speed of 2 meters per second. Now what happens is, after the second collision, B and C combine to form this object D. Now the mass of this object is going to be the total of the masses of B and C, that's 2 plus 3, so that gives us 5 kilograms. And we have to find the speed of D after this collision. So we don't know what the speed here is. Now remember, the total momentum for the system was 24, and it's still going to remain the same because that cannot change in the absence of any external forces. So we can use the same conservation of momentum again. We'll say 4 multiplied with 2, that's the momentum for the first object, plus the momentum of the second object here, that's 5 multiplied with v. This has to equal 24. Now 8 plus 5 times v is equal to 24. 5 times v is equal to 16, and the velocity of the second object comes out to be 3.2 meters per second. So this is the speed at which this object D is moving. Alright, and that pretty much covers all the concepts you need to know about in terms of momentum. So thank you for watching, and let's stop here.